Lexical analysis. At the end of this lesson, you will be able to explain lexical analysis and its role, analyze the interaction between the lexical analyzer and parser, define token, lexeme and pattern, explain lexical errors. You know that the first phase in the process of a compiler is LA, that is, lexical analysis. Let us consider an analogy to better understand the tasks involved in the lexical analysis phase. If a student wants to learn English, he will start learning from the alphabets. Then he will learn to write words combining the alphabets. Once he is capable of writing whole words, he will be eager to know the meaning of those words. So, to know the meaning, he will refer the dictionary, where the predefined words are already explained with its meaning. The compilation process also works in the similar way by forming tokens from individual characters and referring to the regular expressions that can be compared to a dictionary. To know the working of the compilation phase in detail, let us delve into this lesson. When the source code enters the lexical phase, the lexical analyzer or the scanner reads the text, character by character. The main task of lexical analyzer is to convert the lexemes into tokens. In this line, the letters int A, B and C are denoted as lexemes. Similarly, comma, 10 and equal to are also lexemes. The lexical analyzer replaces the lexemes with tokens. For example, int is a token. Similarly, A, B, C equal to, comma and 10 are also tokens. In the process of converting lexemes into tokens, first LA has to identify the possible tokens in the source code. For this purpose, it introduces the regular expressions or RE. Regular expressions are the notations for describing a set of character strings. If the lexical analyzer finds any invalid tokens, it generates an error message by representing the line number associated with the error. The program gets read line by line only in the lexical phase. It also performs secondary tasks such as removing the comment lines and extra white spaces in the source code. At the end of this program, you can see only the tokens, which are the output of this phase. Next, the tokens that are produced as the output are used by the parser to generate the syntax tree, which is the next phase of the compiler. Lexical analyzer sends the tokens to the syntax analyzer whenever it demands. Upon receiving a request from the parser, the lexical analyzer reads the character string until it recognizes the next token. Then, if the lexical analyzer finds any token, it responds to the parser representation. If the token is a parenthesis, comma or colon, then it is represented as an integer code. We know that the lexemes are a stream of characters in the source code that are matched by the pattern for a token. For every lexeme, there is a predefined rule called patterns, which identifies if the token is valid or not. These rules are described by the grammar rules and pattern. A pattern has a set of predefined rules that contain a list of valid tokens. These patterns are defined by means of regular expressions. The lexemes, which are a series of atomic units that can't be split further, are categorized into blocks called tokens. The typical tokens are identifiers, keywords, operators, special symbols, and constants. Now, let us discuss how the tokens are specified in language theory. Alphabets. The term alphabet or character represents any finite set of symbols. They are binary, hexadecimal, English language letters. String. In language theory, the terms sentence and word are often denoted as string. Any finite sequence of alphabets is called a string. The length of the string is determined by the number of occurrences of alphabets. For example, the length of the string mtutor is 6 and it is usually written as shown. A string having no alphabets is known as an empty string, which is denoted by epsilon. Special symbols. The source code also contains special symbols which are arithmetic symbols, punctuation, assignment, special assignment, comparison, preprocessor, location specifier, logical, and shift operator. Consider the separation of the words in a segment of C program as follows. Here, the pattern integer and float takes the keywords int and float for token type. The pattern for complex tokens identifier ID and constant are described by regular expressions notation, which will be discussed in further lessons. The token type literal describes the pattern for anything embedded inside quotations. The tokens are separated as shown in the image. Consider another example of the scanning of the assignment statement. A is equal to B plus C into 10. The sequence of tokens are generated as follows. A, B, and C are the integers, so the token type is ID. Equal to, plus, and asterisk are operators, so the token type is OP. 10 is a constant, so the token type is constant. During the scanning process, the extra white space character is removed from the source program by this analyzer. Lexer is a software program that performs lexical analysis. If the Lexer finds any invalid token, it cannot continue with the scanning. So, it throws an error which is called a lexical error. For example, consider the source code in a C program. Here, the lexical analyzer cannot find whether printf is a keyword or not. Since it is a valid identifier, the lexical analyzer must generate a token and let some other phase spot an error. When a previously recognized valid token doesn't match with the grammar rules, then another error is thrown by the scanner, which is called a syntax error. The lexical analyzer can't proceed because it needs an error recovery solution. This is known as panic mode recovery. There are 4 possible error recovery actions: deleting the successive character, inserting a missing character, replacing an incorrect character with a correct character, transposing 2 adjacent characters. In this case, an incorrect character should be replaced with a correct character. Summary. Let us recall the process of lexical analyzer. The first phase of the compiler is the lexical analyzer, where the source code steps in. The main task of Lexical Analyzer is to convert the lexemes into tokens. It also performs secondary tasks such as removing the comment lines and extra white spaces in the source code.